Hello friends, welcome to my channel. Let's have a look at problem 2383, minimum hours of training to win a competition. So in this video, we're going to share a solution format based on simple linear traversal. First, I'll point out several points in the statement of the problem, and then we go over the idea, and finally we share the code. So this problem asks us to return the minimum number of training hours required to defeat all the opponents. So here are 2 points to be noticed. First is that when we face an opponent, we need to have both strictly greater experience and energy to defeat them and move to the next opponent if available. So and the second point is that defeating the S opponent increases our experience by experience I, but decreases our energy by energy I. So this is the second point. So before the third point is that before starting the next competition, we can train for some number of hours. After each hour of training, so we can either choose to increase our initial experience by 1 or increase our initial energy by 1. So that's the 3 points that are to be important for this problem. So here are 2 examples, so you can have a digest for example 1 following the explanation here. So the constraints or additional assumption for this problem are the following. The first one is a consistency assumption. That is, the energy array and the experience array have the same length, and the length is bounded above by 100, so it's not a very large size problem. So the numbers involved, like initial energy, initial experience, and the energy I and the experience I, are bounded in between 1 and 100. So with that said, let's look at the idea. So the idea actually is rather straightforward. So we are going to do linear traversal. So during the traversal, we're going to check the current energy we have and the current experience we have when we meet the current opponent energy and opponent experience. So first is that if the current energy is strictly larger than the opponent energy and the current experience is strictly larger than the opponent experience, so no additional training is required. So we just update the current energy and the current experience and then go to the next opponent. Otherwise, so the training hours needed are the following. So there are 2 possibilities. First, if the current energy is less than the opponent energy, so we need actually at least opponent energy plus 1 and such a number of amount of energy to be able to beat the opponent. So the number of training hours is the following. That is, opponent energy plus 1 minus current energy. So this is one source of training hours. Another source of training hours are the following. So if the current experience is less than the opponent experience, so we need at least opponent experience plus 1, this amount of experience to be able to beat the current opponent. So the number of training hours is given by this number, that is opponent experience plus 1 minus the current experience. So this is the training hour needed. So actually, after we check each of the if conditions, so we can reset the current energy and the current experience to be the corresponding amount of the opponent, then plus 1, right? So after we do the reset, actually, once we beat the current opponent, then the energy and the experience we have is the following. The current energy minus the current opponent energy, and the current experience plus the current opponent experience. So notice that the current energy and the current experience is after the resets in the above if conditions. So with that said, actually after the linear traversal, we are going to get the desired training hours. So here is actually a detailed walkthrough for example 1. So I'm going to explain the first 2 groups, and then I will leave the other details for the audience. So first, the initial energy is 5, initial experience is 3, so which is larger, both are larger than the first opponent energy and experience, so we do not need training hours. And after beating this opponent, the energy is decremented by 1, so we have energy is 4. And the experience is incremented by 2, so the experience will be 5. So we have 5, 4, and 5. And then when we look at the second opponent, we have the energy is 4 and the experience is 6. So we need 1 hour of training for get energy level 5, and we need 2 hours of training for getting experience value of 7. 7 is larger than 6 by 1, right? So in total, we need 3 hours of training for beating this opponent, right? So that's the 3 here, right? After we beat this current opponent, so the energy will be 1 because we increase that to make it just 1 larger than the opponent energy. And the experience, so our experience after training is 7. And then after we beat this opponent with experience 6, we get 7 plus 6, that is 13. That's the current experience level. So that's this line here. So you can continue this fashion to get 8 at the end. So that's the walkthrough. So next we are going to write the code. Actually, the code is very straightforward. We just need to translate this idea into code format. So for this, I'm going to first initialize a result variable whose final state is what we want to return. Then we're going to introduce 2 variables called current energy and current experience. So current energy, current experience. So the initialization is straightforward. So initially the current energy is initial energy, and the current experience is the initial experience. So this finishes the preparation. So next we are going to do the linear traversal. So we are going to consider for E and E. So the capital E represents energy, so as in physics, right? So the little e represents the experience. So like capital E and little e in zip, so we're going to use the zip function. So for energy and experience. Then what we're going to do is that we're going to check the condition. So what's the relation of the current energy with the current E and the current experience with the current E, right? So we are going to compare and increase the result state. So first, if current energy is less than E plus 1. So in this case, so we're going to need training hours to gain energy to this level, E plus 1. So the training hour needed should be E plus 1 minus the current energy. Then actually we can reset after training. The current energy level will be E plus 1. So this is the one case. Another case is that a situation, let's see, is if the current experience is less than E plus 1. So we need training hours to gain up to this E plus 1 amount of experience. So the result should be incremented by E plus 1 minus the current experience. And then we're going to reset the current experience to be E plus 1 after training, right? So after we check these 2 if conditions, and then, so this is for the current opponent. So now, thus we arrive at this current energy and current experience, we can beat this opponent. So after we beating this opponent, so we're going to reset the current energy and the current experience. So the current energy actually is decremented by the energy of the opponent, and the current experience is incremented by the opponent experience, that is current experience plus E. Notice that this current energy and current experience might be reset after these 2 if condition checks. So that's it for the whole procedure. So once we done this for loop, actually we can return the result state. So this actually forms a full solution to this specific problem. So let's first do a special case check. So yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the generic cases. So I guess that this problem is a straightforward problem, but here, so it's important to notice that we need to do some reset during the process to faithfully count the number of training hours and the state after we beat a opponent, app opponent. So with that said, I guess that's the end of the current video. Thank you very much.